Welcome back, chemistry fans. Today, what we're going to do is Unit 7, and I believe this is topic 3. So let's jump into this homework solution for tonight. We are going to be talking about a multitude of different topics. They seem to be unrelated, but they're all talking about bond energies. All right, so how these things bond together. When we were dealing last class with lattice energy, we would be given an overall energy value for this. They would say all of this equals 350 kilojoules. Well, we need to figure out how they got to that. So what we're going to do is we're going to break this down into individual steps. And we are going to use the formula of products minus reactants. So our products are on the right side, our reactants are over here. So these are reactants, these are products. So we're going to use these values on the right minus these values on the left. Where do we get the values for these bonds of these molecules is down in this table down below. So we're just simply going to match it up. So we find HF, and it says that each one of those molecules to make them is 565 kilojoules. But there are 2 moles, because notice this is per mole, and there are 2 moles. So it's going to be products 2 times 565 minus what it's going to take to make the reactants, because we're using them, so we're losing this much energy, 432. So we're going to lose this much energy. I don't need to multiply it by 2 because this is the H2. The same thing for the F2, minus 154. So we're going to put this all into our calculator, and our calculator is somewhere else, I'm guessing. No, it's right behind my screen here. So we're going to take 2 times 565 minus 432 minus 154, and you get the sum for this step, for this reaction, is equal to 544 kilojoules. That's how much energy must be added to make this reaction occur. Okay, step number 2. What we're going to do is we're going to ask which molecule has a shorter bond. Well, it's the one that has the more bonds in it. The shorter the bond, the more the number of bonds. So if we do the Lewis structure, we would see that N2 has triple bond, O2 has only a double bond. So N2 is the shorter bond. What is the bond angle then for NH3? If we were to do the Lewis structure for this, we would see that it creates a trigonal pyramid. Well, in this trigonal pyramid, all of the bond angles are equal. And you would say, okay, there looks to be 4 different ligands. You divide 360 by 4, it's somewhere around 90 degrees. Actually, though, it ends up being just slightly bigger. It's 109 degrees. Okay, what type of hybridization bond occurs for SO3? So again, we have to know how to do our Lewis structures. And in a Lewis structure, we would see that this bond creates, this molecule creates a double bond on one and single bonds on the others. So this means that this molecule has 1, 2, 3 ligands. So you would have SPP, what that equals is SP2 as the hybridization. All right, formal charge on number 5. What we do is we count the number of valence electrons, you subtract the number of bonds, and then you subtract the number of free electrons. So we are trying to figure out which one of these molecules down here, which are both H2O2, which one is the correct structure. So here we go on the formal charge. So I'm going to start with my H. It has 1 valence electron, and it has 1 bond. That means it has a -1 charge. The same is going to be this for the H on the other side. So it's a -1. So those are my formal charges there. Now the H's, now the O's. The O's have 6 valence electrons, but they have 3 bonds, and then they have 2 free electrons. That means they have a charge of +1. Okay, nothing can be evaluated just yet on this one. However, the goal is to get as close as we can to zero. So let's find out what the other structure has for its formal charges. The hydrogens are going to be the exact same. They have, -2. Where did I get -2? These are not correct. Let's try that again. They have one valence electron, they have one bond, they are zeros. Let's try that again. So the same is going to be true for these hydrogens, going to be equals to 0 because they have one valence electron, they subtract one bond, that's equal to 0. Now let's go ahead and see what we get for the oxygens. Again, we start with 6 valence electrons. We subtract 2 bonds on either side of the hydrogens, and then we subtract 4 for the free electrons, and that also equals 0. So the one molecule that has more 0 formal charges is the second. This is the more favored shape of the molecule, possible structure. Okay, label the sigma and pi bonds. Sigma bonds are all the single bonds. They are also always the first bonds. The pi's are the ones that come secondary and tertiary, third. So we count up how many there are. The sigmas, there are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the pi bonds, there would be 2 of those. This is everything that I wish to share with you about our lessons last class. Thank you so much. We will talk with you again soon. Bye-bye.